Hey everybody, today we're going to go through what is the last lesson of the year for my students. We're going to do trigonometry lesson number 5. And in this lesson we talk about the difference between degrees and radians and how to go back and forth. Now, even though we haven't talked about radians at all, you might have an idea that they exist because when we have been doing our work on the calculator, we look, and this goes for even some of the $10 calculators. This doesn't have to be, a TI fancy pants calculator. It can just be like a $10 scientific calculator. It gives you the option between radian mode and degree mode. And you have to be able to choose between the two. And I have been telling you over and over again, use degrees, use degrees, use degrees. So it's important that we at least talk about what radians are and how to go back and forth between the two. Okay, when you get into higher level math, radians are actually going to be more commonly used than degrees, at least in a lot of cases. So let's talk about it real quick and fill in our notes. All right, so you may have noticed that your calculator shows two different ways to go through this stuff. The first way is degrees, we know that. The other one is what we'll practice today. It's called radians. And to show you how radians work, we're going to focus on a circle. Okay, so let's go through and let's make an angle on a circle. Okay, so what I want you to do is just sketch out an angle. Now we are going to put the first side of our angle right here. That's going to be our initial side. Okay. And then for our first example, let's just do a 45-degree angle. Now, a 45-degree angle, you're not even making it 1/4 of the way around the circle. You're just making it about this far right here. Half of 90. So if we had a 90-degree angle, which would be right here, 45 would be half of that. So right here, we've got a 45-degree angle. Now, the fancy name for the other side is the terminal side. And there you have it. You have demonstrated a 45-degree angle on a circle. Now, as we go around, we've got 0 degrees right here. If we were to make it all the way up to here, we would have 90 degrees. And then if we go back to one of our very first chapters of the year, we learned that a straight line is actually 180 degrees. Now this is where it's going to get a little bit different, and this is going to be part of our radians lesson as well, is understanding how this works. If you kept going, and if you did all the way here, if we were referring to that big angle, not the 90 that's left over, but the big angle, we would call that 270 degrees. And then last but not least, what would happen if you made it all the way back to your original starting point? And people know this from if you're watching a skier or a skateboarder or a snowboarder or whatever. If you make it all the way back around, you have done a 360. Even if you're watching a slam dunk contest, a lot of times somebody will do a 360 dunk. They will do a full turn in the air, dunk the ball, all that good stuff. Okay, so that's another way that you can demonstrate degrees. 90, 180, which you already knew, and then you could keep going to 270 and 360. Now, what does that have to do with radians? Well, radians are sort of based on what's called the unit circle, okay? Now, this is a very, very early basic demonstration of what the unit circle is. So if you ever have a teacher that said, oh, well, no, it's more complicated than that. Well, of course it's more complicated than that. This is just an intro lesson. The unit circle you can think of as a circle that has a radius of 1. So let's say this was the origin. That would make this the point 1, 0. And that would make this the point 0, 1. Then right here you'd have negative 1, 0. And then 0, negative 1. That would be called the unit circle. Now, let's say you traveled the entire way around the circle. We're going to keep our initial point right here, but now we're going to go all the way around the circle here, just like we did with our 360 example over on the left. Instead of thinking about it in terms of how many degrees you traveled, I want you to think of it in terms of how far you traveled. Like if you had to walk all the way around this circle, how far did you go? And when we're talking about distance, that means what we're actually talking about is circumference. Now, the circumference of a circle is either pi times the diameter, or what will be easier for us will be to think of it as 2 pi r. Now, if this is the unit circle and the radius is just 1, then multiplying a number by 1 doesn't change it. So the circumference of this circle would just be 2 pi. Okay? So this would be a distance traveled of 2 pi. Now, what if you only made it half of the distance? That means you didn't make it a distance of 2 pi. That means you only made it a distance of pi. Now, what if you only made it half of that? Well, now you only made it half of a pi, which would be pi over 2. So half of a pi. And then, last but not least, if you made it 3/4 of the distance, so you were somewhere between getting a pi and getting 2 pi, that would give you 1.5 pi, which would be known as 3 pi over 2. That's what they usually call it. Long story short, 360 degrees is the same as 2 pi radians, because radians are just sort of referring to the distance you traveled on the unit circle. Okay. So that means every 360 degrees counts as 2 pi radians. Now, we probably need to clean that up a little bit. Every 360 counts as 2 pi because making it around the circle would take a distance of 2 pi to make it happen. So let's try to clean that up a little bit. Let's say instead of every 360 counts as 2 pi, if 360 counts as 2, then that means every 180 degrees counts as 1 pi, which I'm just going to write pi. So hopefully you can kind of see where I'm coming from on this. Here, let me do a quick demo on the calculator to prove my point. If you did in degree mode, the sine of 90 degrees, let's say. Just short, sweet, simple, it's 1. There's a reason why. We'll talk about it maybe sometime, maybe not. That would be the same as if you were in radian mode and you did the sine of pi over 2, because pi over 2 radians is the same as 90 degrees. Okay, and that would work for every single trig function in the universe. Okay? All right, so how do you go back and forth between the two? You know, how in the world can you change degrees to radians, radians to degrees, all that good stuff? Well, if every 180 degrees counts as a pi, then all we really have to do is change the unit. It's almost similar to some of the things that you do in chemistry class, where you're changing units. You've done it in the past with other things as well, but all you have to do is say to yourself, okay, self, every time I have pi radians, it's the same as 180 degrees. And then just use conversions to take care of business. So what's going to happen is here you're going to simplify and you're going to get 30 pi over 180, which we can't leave it like that. That just seems really, really strange. So let's reduce the 30 over 180. Let's take 30 divided by 180 and then change that to a fraction and you get 1/6, which means your answer is 1 pi over 6. So pi over 6 radians. Now, you should never get one of these wrong because you can always check your work. If you are in degree mode and you did the sine of 30, you would get 0.5. If you are in radian mode and you did the sine of pi over 6, you get 0.5. So 30 degrees is the same as pi over 6 radians, and you can always check your work, so you never have to get anything wrong. All right, let's do problem number 2 here. And I am going to take the easy way out here. I am simply going to replace 30 degrees with 100 degrees. So then when I go across, I'm going to get 100 pi over 180. And then I'm going to reduce 100 over 180. Now you could just divide the top and the bottom numbers each by 20 if you don't have a calculator that'll do it for you. But most of our scientific calculators will do it. we get 5 over 9, which means my answer is 5 pi over 9 radians. All right, let's try it one more time with 150. We're just working on changing degrees to radians, and then we're going to go the other way around. All right, so if we get 150 pi over 180, and then we try to reduce that, you could divide the top and the bottom number by 30. If you have to do this the hard way, you could divide the top and the bottom number by 30. In this case, I'm going to have the calculator do it for me, and I'm going to get 5 pi over 6 radians. All right, how do you go the other way around? Well, if you wanted to go the other way around, what you would end up doing it's not going to be hard to do. You just have to switch the logic that we used before. So instead of multiplying by pi over 180, you're going to multiply by 180 over pi. And again, the reason that we keep doing that, is because every 180 equates to 1 pi. Every 360 counts as 2, which means every 180 counts as 1. Okay, now the calculator's really going to come in handy on this one because we don't even have to worry about the pi's. I don't know if you noticed, but the pi's, we have a pi on top, we have a pi on bottom. That means they're going to cancel out, and all we have to do is 7 times 180 divided by 4, and you get 315. That's it. We got it. It's over. 315 degrees. That's it. So if you had 7 pi over 4 radians, it would be 315 degrees. Okay. Boy, that went pretty nice. Let's do it again. All right. Once again, the pi's are going to cancel out. There's going to be 1 on top, 1 on bottom. So 3 times 180 divided by 2 is all you're going to need in order to get this thing right. And that's going to be 270 degrees. All right, last one. 5 pi over 2. The pi's are going to cancel out if we use units to do it. I can move my calculator over here, actually. So 5 times 180 divided by 2, 450 degrees. Now, for the sake of what we were doing with solving triangles, 450 degrees sounds like a pretty ridiculous answer. It is, but I want you to think of it in terms of the circles that we had up there, where it's actually what you would get if you went all the way around a circle and then you went another quarter of a turn. Okay, that's what it would look like. All right, last part of the lesson. Find a positive and negative angle coterminal with the given one. So in order to understand this, I think we're going to be better off going back to the visual of a circle. Okay, so we're going to go back to that idea. You know, we talked about how this is 0 degrees, and then if you were to go around, you would get 90. And then 180, 270, and then ultimately 360. Now here's what I want you to notice. 0 and 360 are at the same spot. Because if you make this your initial side right about here, and then you were to go all the way around the circle and then land at the exact same place that you started, you did a 360. They ended at the same spot. It actually goes back to the vocabulary that we did in the beginning with terminal sides. If you have two angles that terminate at the exact same place, they are called coterminal. So, for example, 0 and 360 are coterminal. Okay, or let's take it to the next level. 90 and 450 are coterminal. Because if you were to go 90 degrees, okay, so that would just be a right angle right here, and then you were to go all the way around and then go even more and end up at 450 degrees, they would end at the same place. The terminal side would be the same for both of them. So they are coterminal. They share a terminal angle. So how can you make a new angle, positive, negative, whatever, that is coterminal with the given one? Well, it's just an extra turn. So if you have negative 130 degrees and you want to make a positive coterminal angle, just take that amount and go an extra turn. Now, negative 130 means you were actually going the wrong way in the first place. So negative 130 would actually have been right about here. Okay, that would have actually been negative 130 because you're going the wrong way. So the way to get a positive coterminal angle would be you would have to turn around, go back to the beginning, and then go around positively back to that place. My drawing is getting a little bit messed up right now, but that's okay. Let's talk about what we would need to do here. If you want to go in the positive direction one more turn and then land at the exact same spot, then what you would have to do is add 360 degrees. Okay. So negative 130 plus 360 is 230 degrees. So that is the positive coterminal angle. Now, what about a negative coterminal angle? Well, you would take your initial number, and instead of adding 360, you would subtract 360. And that would give you negative 490 degrees. That's not the degree symbol. All right. All right, let's try this again. So if you took negative 300 and you added 360 to it, you would get 60 degrees. That would be a positive coterminal angle. If you wanted a negative coterminal angle, you would have to subtract 360 and you would get negative 660 degrees. So basically every turn is 360 and you can add or subtract based on that amount. All right, now if we're in radians, then we can't add or subtract 360. What we have to do instead is add or subtract whatever 360 would be, which is 2 pi. So that's what we're going to do. We're going to add 2 pi, or when we do the problem a second time, we are going to subtract 2 pi. Some people actually think it's easier just to change this to degrees, then add or subtract, and then change it back to degrees when they're, or to radians when they're done. I'm not sure I'm a fan of that. It's okay. I probably wouldn't do it myself. You know, I mean, if you're really looking for the easy way out, why don't we just take -5/4 and add 2, which is the same as 3/4. Now notice I didn't use the pi's when I was working through it on the calculator. Okay. Or we could do -5/4 minus 2. Once again, leave the pi's out of it. It's like me at Thanksgiving dinner. Leave the pie out of it. All right, and that would give you -13 pi over 4. Now, real quick, I want you to write something down on your paper before you quit for the day. There's one extra problem that I want you to write down, and I want you to write it down because you're going to see it on Monday anyway, so you might as well be prepared. Let's say you had to find a positive and negative angle coterminal with 540 degrees. Okay. So if you were looking for a positive angle coterminal with 540, you would actually have two different options. You would actually be able to do 540 plus 360 or 540 minus 360 because both are positive and coterminal. So if you put 900 degrees, I would give you points. If you put 180 degrees, I would give you points. Both are positive and coterminal. So then the question would become, how do you do a negative coterminal angle? Well, the trick is, if you subtract 360, you're still in positive territory. So what are you supposed to do? Well, take the result that you got and subtract 360 again. So you do 540 minus 360, but that's still positive, so you have to take away 360 again. So then you end up getting 180 minus 360, which would actually be negative 180 degrees. So sometimes when you do this trick about positive and negative coterminal angles, you have to do the operation more than one time to get out of the territory that you want to be in. Okay? So in this case, just doing it one time doesn't give you what you want. You have to do it multiple times. So, anyway, I hope that helps get you started on degrees versus radians, and maybe it'll explain a little bit about how your calculator works as well. Thank you for watching. Appreciate you tuning in to all the YouTube videos this year. This is actually the 21st video that I've made since we started staying at home, and so I hope it's really helped steer you in the right direction. It's been fun to do. I appreciate your time, and I look forward to seeing you all again real soon. Thanks a lot.